Assalamualaikum warahmatullahi wabarakatuh. My name is Najihah and I'm going to present about a review on biorefinery approach for cassava peels. These slides will cover on introduction, methodology, contents, conclusion, and recommendation. Without further ado, let's move to introduction. Cassava is one of the biggest agricultural crops harvested primarily in many countries, especially in Asia, Latin America, and Africa. In Southeast Asia countries alone, the production of cassava reached 74.8 million tons in 2019. As the production of cassava increased, the waste produced from cassava is also increased. Cassava peels waste can be converted to other value-added products such as biofuels, sugar, formic acid, levulinic acid, glycolic acid, and ferulic acid through biorefinery. Biorefinery is a facility that integrates biomass conversion processes and equipment to produce fuels, power, heat, and value-added chemicals from biomass. Utilization of cassava peels to produce value-added products can help to reduce pollution. Next is about the methodology. There are 4 steps that I followed in preparing this review, which are searching, screening, filter, organize, and report. In searching process, I found the articles through Google Scholar, ResearchGate, ScienceDirect, and NCBI. Some keywords used were cassava peels, biofuels, biorefineries, lignocellulosic materials, and pretreatment. Then, the journal's articles were saved in local files in desktop or using Mendeley. In screening process, I start skimming through title, abstract, result, and conclusion first to identify if it fulfilled the inclusion criteria. The paper must also be in English, and I make sure the report is acceptable. In third process, the journals were filtered and articles with exclusion criteria were removed. The filtration was done manually by reading one by one of the articles. Around 100 journals articles retrieved from the database. I prioritized current articles. In the fourth step, organize and report, I arranged the journals by author's name and year and subtopics, and using guidelines were used for this review paper process. I have read over 100 papers but only took 68 of them as my references because it includes inclusion criteria. Now, let's move on to the contents of the paper review. Cassava peel is the remnants that are mostly produced by industry from pre-cleaning process, which consists of peel, inner peel, and cassava tips. These remnants are often used for animal feed. However, it causes consequential environmental drawback. Therefore, cassava peel or its waste in general appeal more as a source of bioethanol production and other chemical derivatives because they are rich in cellulose, hemicellulose, and have considerably low lignin content. These are the 3 main components that make up lignocellulosic materials, which are cellulose, hemicellulose, and lignin. Cellulose is made up by several 2000s of units of glucose that are connected by beta-1,4 glycosidic bonds. Hemicellulose is a branched heteropolymer that made up of different hexoses, pentoses, D-glucuronic acid, and acylated sugar, while lignin is a product of condensation of 3 monomeric phenol alcohol. This diagram shows the processing steps of biofuel production. I will explain briefly the major steps. Firstly, cellulosic biomass from cassava peels will undergo pre-processing and pre-treatment. And then hydrolysis process either by acid or enzyme is done. Then fermentation process is allowed before it can be converted to bioethanol. Pre-treatment involving lignocellulosic biomass components can produce some valuable chemical derivatives such as ferulic acid. As I mentioned earlier, pretreatment is one of the steps in processing of cassava. It functions to get rid of recalcitrant components such as lignin, as well as provide easy access to cellulose and hemicellulose. In cassava peels especially, pretreatment is done to remove cyanide content that naturally present in cassava. Basically, there are four types of pretreatments. It is an important method used in converting lignocellulose from cassava peels into sugar. Although they all work differently, as shown in the slide, the goal is the same, which is to allow easy access to cellulose and hemicellulose. In cassava peels, the best pretreatment is by using chemical pretreatment, particularly concentrated acid. This is in accordance to a study by Ovuni and his co-researchers, which stated that pretreatment by using sulfuric acid yield the highest result, followed by sodium hydroxide and ethanoic acid. Saccharification is a process of breaking down complex carbohydrates into monosaccharides. It can be done through acid hydrolysis or enzymatic hydrolysis. Acid hydrolysis is a chemical method which involves the usage of dilute acid or concentrated acid, such as hydrochloric acid. Its benefits include lower cost and faster reaction. Enzymatic hydrolysis, on the other hand, is a biological process carried out by hemicellulosic enzymes such as cellulase enzyme. It is arguably more effective because it generates low toxic compound and it produces high product yield as well as less chemical requirements. Palm oil is one of the biggest plantations in Malaysia. Here, I want to compare the suitability of bioethanol production from palm oil waste and cassava peels waste. Lignocellulosic materials from palm oil contain higher lignin content compared to cassava peels. High lignin content in bioethanol production is undesirable. They also require delicate care whereby cassava can survive even the harsh weather. Palm oil also have slower growth rate compared to cassava. Table 1 shows the chemical composition of cassava peels and palm oil empty fruit bunch, a waste produced from palm oil industry. Although there are not much difference between cellulose and hemicellulose content, there is significant difference in lignin content. This mind map summarizes the value-added products that can be produced from glucose of cassava peels, which are bioethanol, formic acid, levulinic acid, glycolic acid, and ferulic acid. Glucose is a major product from utilization of cassava peels. Previous research discovered that glucose recovery of cassava peels could rise up to 80% through enzymatic hydrolysis using mixture of cellulase and beta-glucanase enzyme. Formic acid and levulinic acid are accessible through hydrolysis process of lignocellulosic materials. These chemical derivatives can be used in many industries as stated in the slides. Another value-added chemicals that can be generated from cassava peels waste is glycolic acid. Tapsons and his co-researchers reported a pathway to create glycolic acid is through the aid of a Levy acid catalyst, converting glycol into glycolic acid. Among the usage of glycolic acid is as an agent for chemical cleaning and metal chelation, and it is also used for a formulation in cosmetics. Ferulic acid is another value-added chemicals that are released as a byproduct from pretreatment process. It is a precursor of vanillin, which is a highly valuable aromatic and flavor components. Lastly, we look on conclusions and recommendations of my paper review. In conclusion, utilization of cassava peels help to conserve and preserve our environment by helping to control waste management, especially in developing countries where cassava is mainly produced, thereby reducing pollution. In this review also, different types of pretreatment were discussed to make sure high quality of bioethanol with the highest yield could be produced. Besides biofuels, chemical derivatives such as glucose, formic acid, levulinic acid, glycolic acid, and ferulic acid can be produced from cassava peel. Recommendations for these studies are, in the future, different types of acid can be used because different acid will yield different results. Next, as cassava peels composed of various components, different types of enzyme for hydrolysis can also be used and explored. Waste management in agroecosystem can also be explored in the future. These are the references used for this presentation.